You are welcome to today's episode on chemistry, balancing of chemical equation, just like where we stopped last time. You know, in our previous lesson, as we watched in the last episode, we have symbols, formulae, and balancing of chemical equations. Now, we've treated about symbols, which I gave you through the use of 20 elements, and why some element answers the name that they answer. I don't know how many of you that can remember the meaning of all those symbols, just as we've discussed in our previous lesson. Today, without wasting much of our time, we are going into balancing of chemical equations. Now, don't forget that balancing of chemical equations is just from also all those elements. Just like as we have sodium, when you come to write it in full, you write SODIUM, sodium. But when you want to write the formula, it will be Na. That is the symbol of sodium. The question is, why? So why? Because sodium came from Latin word, and that Latin word simply means natrium. We have plumbium, we have ferrous, which is iron, and many of them. So because of that, we are still going to use all those symbols to balance chemical equations. And when we talk about chemical equations, we are talking about the combination of two or more elements as a chemical. Just like, not when I say chemical, you talk about insecticide and herbicide. No. So when I'm talking about chemical, I am talking about when there is a mixture between two or more elements. So like when you go to lab or chemistry laboratory, you see where they put chemicals like formalin, formaldehyde, sodium chloride, sodium hydroxide, potassium hydroxide, potassium chloride, silver nitrate. All these are chemicals we see in the lab. Now, because of that, we are going into the balancing of chemical equations. Now, for you to balance chemical equations, there are things that you put into consideration. You can't just balance chemical equations just like that. There are rules you put into consideration. What is this number one rule? Number one rule is that, one, you will not add anything on the subscript. When I talk about, if I say subscript, I mean if you have sodium like this, you cannot just balance equation using putting 2 here. No. These two will only occur as a result of the valency combination. Just like what we treated last time when we are doing about valency. That is the combining power of an element. Now, for example, we have sodium. Sodium belongs to group 1. And because of that, it has one valency electron. Now, I can have another one like chlorine. Chlorine belongs to group 7 and it has a valency of 1 also. If this and this combine, if I want to put them sodium chloride, simply I'm going to have sodium will take this one of chlorine, while chlorine will take one of what? Sodium. 1 times Na is the same thing as what? Na. 1 times Cl is the same thing as El. And this becomes what we call sodium chloride. And don't forget that sodium chloride is just like a normal salt that we are using. The normal salt you use at home is what we call sodium chloride. When you buy sachets of salt, look at the back of that nylon. You will see where they write NaCl, sodium chloride. Now, watch another one I'm going to do here. What if I have magnesium, which is Mg, and chlorine? You will see that there will be a different thing. Now, magnesium belongs to group 2. Why this belongs to group 7 and has 1 valency? This one belongs to group 2 and has 2 valency. If 2 of them combine, you will see I'm going to have Mg1, YCl 2. So 1 times Mg is the same thing as what? MgCl2, magnesium chloride. So it is only by the combining power that you are going to see 2 here. But for you to balance your equation, you are not going to put 2 here. it is only by the combination that you are going to see 2 as a subscript. But if you want to balance your equation, please don't just go and put 2 here. Say, because of that, supposing that I have NaCl, which is supposed to be like this, and I want to balance the equation, I will now go and put 2 here. No, it's not wise in chemistry. Therefore, let's have some balancing of chemical equation. Now, if you are balancing the chemical equation, another rule that you must adhere strictly to is you make sure that the reactant and the product side are equal, well balanced. The same thing that you have in the reactant side is the same thing you are going to have in the product side. For example, I have something like hydrochloric acid plus silver triosonitrates, silver trioxonitrates 5. Now in this case, I want to balance the equation. Then let me see my product. These are the reactants. This side become the reactant. Why this side? In this place, if I want to get this equation, I'm going to have silver chloride plus hydrogen trioxonitrates. These are the 2 things that I'm going to have. Now in this case, if I want to balance this equation, the first thing I'm going to check is the number of hydrogen atom. Now, how many hydrogen is here? 1. How many hydrogen is this side? 1. Making 2 of them balanced. How many chlorine is here? 1. How many chlorine is this side? 1. Making them balanced. Understand that this side is the product side. The product, I have reacted my 2 chemicals, and look at what I got in my product side. Now, how many silver Ag is here in the reactant side? 1. How many silver is in the product side? 1, making 2 of them balanced. Now, how many nitrogen is in the reactant side? 1. How many nitrogen is in the reactant side? Sorry, in the product side? 1, making them balanced. Now, how many oxygen is in the reactant side? This 3 here is affecting oxygen, making oxygen to be what? Become 3. If you go to this side, this 3 is affecting oxygen, making oxygen to become 3. Therefore, we have 3 in the reactant side and also 3 in the product side. This is enough to balance chemical equation. Now, I can have another one in this form. Sodium hydroxide plus hydrogen tetraoxosulfate 6. Now in this case, what am I going to have? Watch what is going to happen here. All in the combination power valencies, all tetraoxosulfates has valency of 2. All tetraoxosulfates has a valency of what? 2. Sodium has the valency of what? 1. Hydrogen has the valency of 1. Hydroxyl group has the valency of 1. Watch what is going to happen now. Now in this case, I'm going to have a combination. Sodium will combine with tetraoxosulfates. Sodium and the tetraoxosulfates. Now since sodium has 1 and tetraoxosulfates has 2, so that for you to see the product that is going to occur, you cannot just write sodium tetraoxosulfate just like that. No. For you to get this your product, you must write it the way that it has a chemistry meaning. So in this place, as I want to combine this my equation, since this one is 1, this one is 2, so I have to carry this 2 to this one, to sodium. Therefore, this become, if they combine, I'm going to have Na2SO4 1. So if 1 multiplied by all this is the same thing as SO4. So because of that, if I want to write this one, the chemical meaning, I'm going to have Na2SO4. Why? Remember, I did not use these 2 here for balancing of chemical equation. Why these two appear here is because of valency transfer or exchange of what? Valency, combining power. This one has 2, this one has 1. So because of that, they have to exchange it for them to react. That is exactly what takes place. For me to balance, I must balance by the side. Balance by the side. I cannot use the subscript for balancing of equation. Now coming to this side, sodium and the H2 surface has gone. Then I have hydrogen and what? Hydroxide group. Therefore, I'm going to have water in this side. Water. These are the 2 things that are going to form. Now, the question is the equation on the board balanced? The answer is what? No, it's not balanced. Why? Sodium is how many here? 1. Sodium becomes how many here at the product side? 2. Remember, I have told you that here is the product side, while this side is the reactant side. So, sodium is 1, while sodium is 2 here. So, how do I make sodium to become 2 in this side? Simply add 2. Then once I add 2 here, how many sodium is here now? 2. How many sodium is here? 2. Now, let us check oxygen. How many oxygen is here? Because this 2 is affecting both of this oxygen here. 2 times oxygen is the same thing as 2 oxygen. 2 oxygen plus this 4 oxygen here, making 6 oxygen. Now we have 2 oxygen here. This 2 oxygen, because 2 times oxygen becomes 2. 2 oxygen. How many oxygen is here? 4. So 4 plus 2 is going to give me 6 oxygen in the reactant side. Now let's check the product side. I have 4 oxygen here plus 1. 4 plus 1 is 5. Whereas this one is 6. Is this balanced? No. This side is 6. Whereas this side is 5. It's not balanced. Therefore, you have not gotten your chemical balancing of your chemical equation. So what will I do to make this side 6? As this side of oxygen is 6 in number. Let's quickly add 2 here. So 2 times this oxygen, that is 2. This 2 plus 4, making 6. And if you check this side, 2 times this oxygen 2 plus this 4, 6. It's non-balanced. Now we check other element there. Another one there is hydrogen. How many hydrogen is here? 2. Because 2 times hydrogen is the same thing as 2 hydrogen. 2 hydrogen, how many hydrogen is here again? 2. So 2 plus 2 is going to give me 4. 2 plus 2 is going to give me 4 in the reactant side. Now, in the product side, do we have 4 hydrogen there? Yes. 2 times 2, 4, making it balance. Which another element? Okay, let's check sulfur. How many sulfur is here? 1. How many sulfur is here? 1. So this my equation now is non-balanced. If you check all of them very well, 2 sodium, 2 sodium, 2 hydrogen plus 2 oxygen plus 4 oxygen, making 6. 4 oxygen plus 2 oxygen, making 6 complete. 2 hydrogen plus 2 hydrogen, making 4. 2 times 2, 4 of hydrogen. So equation is now what? Balance. Now let's get another one. We have equation like this, chemical equation like this. Look at the chemical, hydrochloric acid and sodium triisocarbonate 4. When 2 of them react together, what am I going to have? Look at what I'm going to have. I'm going to have sodium chloride, that is number 1, this sodium and the chlorine here, plus this is triisocarbonate. I'm going to reduce this to carbon 4. Hydrogen, there's 1 hydrogen here and 1 oxygen is is missing from this place. When I combine two of them together, it becomes water. Become water. Now the question is, when you see something of this nature, is the equation balanced? Because anything that you are solving, even by the time you keep on washing and will move ahead, to the extent that will enter into titration, what we call the quantitative analysis and qualitative analysis. Under quantitative analysis, for you to calculate the concentration of your acid in mole per dm cube and the concentration of base in gram per dm cube, the concentration of base, the volume of base, the concentration of acid and the volume of acid, it must have a number ratio where you have any A all over what? Any B. That's the mole number ratio of acid all over the mole number ratio of base. So without well balancing of the chemical equation between the acid and base, you see that you find the calculation difficult. Not only finding it difficult, you will mess up the whole of the calculation. That is why you must get to know how to balance chemical equation. Now with this, if I have equation like this, is it balanced? Then if you watch it very well, you see that it is not balanced. How? How many hydrogen is here? 1. Now go to the product side, 2 hydrogen. So it's not balanced. So you have to find all possible means to make sure applying the chemistry principle to balance this chemical equation. Now I have 1 hydrogen here, I have 2 hydrogen. I have 1 chlorine here. Okay, I have 1 chlorine. That one is, there's no problem in chlorine matter. Now I have 2 sodium here. I have 1 sodium here. It's not balanced. I have 3 oxygen here. Okay, I have 3 oxygen this side, 2 plus 1, making 3. Balance. So let's just balance these ones that are incomplete. Now, since I have hydrogen here, what will I do to make this one 2? So I will simply add 2 here, 2 hydrogen. And since I have added 2 here, 2 is affecting hydrogen, it is also affecting chlorine, making chlorine to become what? 2. 2 hydrogen here, 2 hydrogen here, balance. Now in terms of chlorine, 2 chlorine here, 1 chlorine here. So let me just add 2 here. So once I add 2, making chlorine 2, making chlorine 2 this side. Sodium is how many here? 2. Sodium is 2 here. Carbon is how many? 1. Carbon is what? 1. Oxygen is 3. 2 plus 1, making 3. And the chemical equation is non-balanced. So these are the things that we are talking about under chemical balancing of chemical equation. You must learn how to balance chemical equation, because some cases where you just bring incomplete equation. So it's left for you to balance it and get the normal answer. Once you arrive at the normal balancing, then you forge ahead with your calculation.